So hey everyone, I'm going to be talking about Eclipse MicroProfile. Alright, so what's the reason for Eclipse MicroProfile? So the move towards microservices from a monolith to smaller componentized services. I'm not sure how much I believe these numbers, but surveys say that about 30% of customers are already in production with microservices. I should talk a little bit about what are microservices, what's the point of them. Basically, problems with monoliths include you have a single address space, so that can cause class loading issues, other problems like that. You can't update as easily a monolith, and if, for example, you have one component has a dependency on a 2-year-old SLF4J, then you're kind of stuck with that. And of course, moving to the cloud. So with microservices in mind, back in 2016 at a Java 1 conference, a couple companies came together to think about how to create microservices for more traditional enterprise Java shops. These are the companies that are currently part of the MicroProfile community. It's IBM and Red Hat, I find, are two of the biggest, but others, including Oracle and Microsoft. If you want to look at this yourself after, microprofile.io has most of the details. So what are the features of MicroProfile? And I'll go through all these in detail. Number one, RESTful. So everything is JSON and REST. Configurable. Fault tolerance, so dealing with retries, timeouts, things like that. Discoverable, OpenAPI publishes information about each service. Secure JWT tokens. Traceable, automatic tracing of web service requests. So back in 2016, the core components came out in version 1.0. And this is the latest release, 2.2. And I'll cover all of these components. And by the way, if anybody wants to interrupt, I have no problem with that if you want to ask any questions. So these are the current vendors that support MicroProfile. We've got Tommy, OpenLiberty, many others. You can see the whole list on this Wikipedia page, on this Eclipse wiki. All right, so we're going to go through each component of MicroProfile. And again, if you have any questions, speak up. So one of the major core components is called CDI, Context and Dependency Injection. So this is just a classic dependency injection framework. In this case, the add inject annotation injects either a singleton or a request-based bean. Just a couple of notes for those that aren't aware. When you create the bean, you create the bean by either annotating it as a singleton with application scoped or per request with request scoped. So JAX-RS is the way that REST is implemented in MicroProfile. So pretty simple, all mostly annotation based. The app path defines the actual URI where the web service is accessed. Produces is the content type, the MIME type of the content that it produces. Consumes is the request MIME type. And then each method you define as actually implementing the web service. So in this case, we have a start coffee brew method, which handles a post request and responds with a response object. Now, for the client, I mean, of course, you can use any REST client. In Java, you could simply use the JAX-RS client. That's done by many. But MicroProfile introduced what's called the REST client, which is a way to create a more type-safe way for clients and servers to interact. So the add-register REST client annotation is placed on an interface, which defines both the client and the server implementation. And it's very similar to the server end of it, but on the client end, you just have the interface, and from the interface, the the runtime actually does the full request. So you don't have to actually build a request object, you figure out all the details of how to serialize things. So a couple notes on the REST client. When you actually need to use the client, you just use add inject at REST client on, this is all CDI that's injecting the client, and then you just simply call, in this case, start a coffee brew. So you don't even have to use any JAX-RS methods. There are ways to hook into JAX-RS processing through the register provider for those familiar with JAX-RS. So for example, you could handle a 404 and throw a certain type of exception. But you could do pretty much any sort of pre or post processing of JAX-RS requests and responses. By default, the client has the dependent annotation. What that means is that it picks up the scope it's in. So for example, if it's in an application scope, then that means you're only going to have a single REST client. So that avoids, all the overhead of establishing the actual client. So we have the endpoints. In between is JSON through both JSON-V and JSON-P. And this is just simply the serialization, deserialization of the request and the response. You're only dealing with Java objects, and it's handling all of the serialization, deserialization. In this case, we have a simple POJO, and in the web service JAX-RS implementation, we accept coffee brew, which is that POJO, and then, so somebody will create a coffee brew object, send it over the wire. That's all serialized and deserialized. So you're just dealing with the Java interfaces. OpenTracing, so just a little bit of background. So when I'm not at customers, I do development for WebSphere Liberty at IBM, and IBM is part of one of the major implementers of MicroProfile, both the spec and the implementation. So this is actually what I worked on. OpenTracing is a way to automatically time and track requests as they flow. So microservices, one of the major problems with microservices, now you have this sprawl of services throughout. One request might call 10 web services. So OpenTracing automatically follows a single request through all of those services, uses a correlation ID, and then you can publish that information to a backend like Zipkin or others. So this is a standardized way to publish information about requests as they travel through. It also gives you the timing, so it's much easier to understand where a request was slow. Now, this is also a good example of how one of the purposes of MicroProfile is to reduce code and make it standardized. So in this case, when you enable OpenTracing, you don't actually have to do anything. Any JAX-RS request or handling a JAX-RS request is automatically traced. So this is one of the benefits of MicroProfile. You don't have to do much. You would just set up a Zipkin server, whatever your backend is, and the information would flow. You can disable uncertain services if you want. In this example, this also shows how you can also trace a method within a JAX-RS service. So that way you can see the timing of parts of the service instead of the whole service. And from here, for example, let's say Start Brew makes a call to another JAX-RS service. The OpenTracing runtime will figure all that out and correlate all that all the way back through to the request. MicroProfile config is just a standardized way to do configuration. Very simple, nothing complicated here. So in this case, you do an inject, again, using CDI, and you define the config property annotation. You give it the name. You can also give it a default value. And I'll go through how you actually can specify the values, but there's a lookup order. So first, it takes the default value, if there is one. That's overridden by any static configuration in the MicroProfile config.properties. That's overridden if there's an nvar with that name, and that's overridden if there's a -d JVM argument with that name. So there's a hierarchy of, and you can actually change this hierarchy if you want, but this is the default. You can also build custom implementations of the config loader. So for example, if you want to load from JSON or reload dynamically. And you can do serialization, deserialization of different types, custom types beyond strings and booleans, and basic types. So fault tolerance is kind of a bit more advanced. I mean, a lot of what I've been showing is pretty simple, just kind of standardizing the basic stuff. Fault tolerance has a lot more features. So this is an example where you have A is calling B, and if there's a timeout, fault tolerance will automatically retry. So in this case, we have the retry on, was just saying which exceptions to retry on, the maximum number of retries. Max duration is for all the retries combined, and so just to block the whole request. So pretty simple, but pretty powerful automatic handling. And fault tolerance has a lot more features. So retry, you can actually add a jitter option. So the jitter option will, so you'll say, for example, if there's a timeout retry after 5 seconds, you can add some jitter to reduce the probability that you're hitting some sort of odd condition on the back end. Timeout makes it very easy to configure the timeout on each remote request. And of course, all of this is also integrated into the configuration stuff. Circuit breaker is nice where you can fail. So there's a rolling window of requests. So let's say 20 requests. And if a configurable proportion of those requests fail, then the circuit opens and that service will immediately throw an exception. Then you configure a certain amount of time after that where it'll go into a half-open state and it'll start letting some requests back in, and if a certain number of those succeed, then it goes back to a closed circuit and it's working again. All of those parts of that are configurable. Bulkhead is a quick way to throttle a service. So you can say, for example, no more than 30 concurrent requests to a service. And once it hits that limit, you can control whether it throws an exception or calls a fallback service. MicroProfile Health. Again, this is, I think, a good example. This is a trivial service, but this is a way to standardize what every customer needs to do, which is to have a health check API. So in this case, you implement the health check interface, which has this call method. You do your check of whether or not your service is healthy, and then respond either down or up. I mean, the ultimate idea is that once all of these pieces are standardized, then the infrastructure will start to automate a lot of these things. Metrics is really nice. All you do in this example, you add a metered annotation, and the runtime will monitor the number of requests, the rate of requests per unit time, the response time of that service. So really quick and easy and standardized way to monitor the health metrics of requests. So metered is actually just a way to specify multiple annotations. You can specify them individually. So timed is just timing the number and duration of requests. Counted counts the number. And gauged is a kind of separate thing from metered, where you can say, how many items are in my inventory. So it's just a way to provide some metric, application-defined metric. JWT is integrated into MicroProfile, so this handles integrating with the authorization in, let's say, an EE container or just more generically. So in this case, you can say roles allowed, and it will check whether the the token has those roles. And so if you want access to the actual token, you can just do a request scoped JSON web token inject. So you have access to the whole JWT token. And then you can look at custom claims. The Open API specification is a way to describe services. I mean, a lot of these things have been done decades ago. It's nothing really that new, just kind of for the new technologies. This is describing a service in YAML. This is actually based on Swagger, for those that are familiar. And you basically can control all of it, but even just a simple annotation will do a basic reflective analysis and create that. There are a bunch of guides here that walk you through demos. If you're interested, openliberty.io/guides. And I think Paul will make this presentation available for everybody. So now I'll show a quick little demo. So first I'll just show the code. So in this case, here we have a web service. It's at the path, the URI is warm hello. We can see here we're injecting a bunch of configuration values, in this case some zip code, things like that. Here we have the REST client to a remote web service. In this case, there's some weather service. Here we've got a JAX-RS endpoint. Notice we've got metered, so it's going to count and watch the duration of requests. It's a GET request, produces text plain response, and then this is for OpenAPI to describe the operation. And then here we can see how easy it is to use a remote web service. So in this case, this remote web service has been injected, and all we have to do is call the type safe method, and then read the response and return the response. This is the interface for the client for the remote web service. Pretty simple. And then the forget where the implementation is, 1 second. Oh, that's right. The implementation is actually on a remote website. And so the way we configure that is through, and again, you could do this through many different ways, but the simple way is through a static configuration in the app, which points, you use the class name /mprest URL, and then you point it to the actual endpoint of the JAX-RS service. So when I execute this service, pretty simple. This is actually making a remote call to some other web service. This is the Health MicroProfile service. So this is going to be running the actual health check. So anytime I request a service, this is the JSON that's going to be returned. This is the default metrics implementation. So this isn't very beautiful, but it's more designed for some sort of service that will consume this, not really for humans. But just to quickly show, this has both information on the JAX-RS services and also JVM metrics. So for example, it's got total class load count, CPU load average. I mean, the stuff that you would expect for basic monitoring. And then within that, just gotta move this thing. There we go. So this is a subset of the metrics for a particular application. So this shows, for example, this is the name of the service, and then in this case it's rate per second because we're metering it. We've also got the total counter. So this gives you the number of executions of that service. And then we've got rates per second, per 5 minutes, things like that. And then finally, we've got, this is automatically generated from the annotations. This is a description of the web services that are there. So I blew through that pretty quick, but that is the essence of it. So I think that's it. Any questions? Yeah.
Does this come with a like an application server, or is there one built in, like an embedded Tomcat or something like that?
So there's no reference implementation, but Tommy has one. So there's a list of who implements MicroProfile. So oh, jeez. So these are all the so far who's implemented that. So I don't know the details of why they decided not to provide a reference implementation. All that's provided is a TCK, which tests that an implementation is conformant. But then these are the implementations.
Compared to the Spring framework, what's the benefit for this one?
Yeah, that's a good question. I'd say it's a direct competitor. I don't know Spring well enough to say where it's better and where it's worse. So, yeah.
One thing I know about Spring is it tends to be kind of a lot of dependencies that they've carried from sort of legacy stuff, and so I'm wondering, what is the minimal sort of deploy size of a MicroProfile app?
I know that the basics, I mean, if you're just using JAX-RS, where was that? CDI, though, is pretty heavy. I mean, like, if you look at Weld or something, it's pretty heavy. So it's not going to be trivial. But I could look up what that would be. Let me take some notes. Is there another question?
So yeah, it looks like, I mean, it's mostly geared towards RESTful services or whatever, right? So I mean,
Yes.
they're not trying to do like an MVC type of a thing or whatever that's going to provide. Anyway,
Right.
Is there any container managed transaction type of stuff or whatever?
There are early stages of that there's a plan to do that. But you're right. So you'd have to build something like NVC on top of this.
What's the difference between this and E?
Right. So this is really just a new version of EE. That's why I look at it.
Okay.
It's supposed to be lighter weight. It's JAX-RS based. You could, but for example, EE, there's nothing like a automatic metric service using just simple annotations or health checks. You're building that all on your own. So I look at it as less of technology and more of standardizing for this new world that we're being pushed into. That it's, once you know there's going to be a metric endpoint with this particular JSON output, it's much easier to integrate. I think OpenTracing is the best example of that, because how hard is it today in an EE environment to understand flows of requests through a set of servers? You're usually rolling your own thing. Right now, you don't even have to do anything as long as you're using JAX-RS, and you just fire up a Zipkin server, and suddenly you've got all of your requests flowing into that. So that's the way I look at it. I might not be pitching it the way others would, but it's certainly re-implementing a lot of EE in hopefully a lighter weight way and a standardized way for the cloud. That's the idea, I'd say.
So I saw that I guess Eclipse didn't really reach an agreement on the Java trademark, and a lot of questions there. I'm looking just at these packages. The CDI is maybe the only Java X one, right? Or is there or other of these Java X, and is there any concern about sort of MicroProfile going forward in the future?
So JAX-RS is Java X.
Is it,
I don't know offhand about the others. What do you mean by concern? What kind of concern?
well, I guess there was like if they go forward with the Jakarta project, then anybody who's got Java EE based code is going to have to change all their source, break source and binary compatibility going forward for the next version, presumably. So I was just wondering if if this was going to essentially face that same pain. If we built a MicroProfile app today, in MicroProfile 3.0, are we going to have a backwards compatibility, source and binary compatibility breakage?
That's a great question. I don't know, but I can talk to some folks on that.
And it came out fairly recently that Jakarta is re-implementing that whole namespace. Or,
Really?
yeah.
Yeah.
Wow. Yeah, I didn't hear about this.
Yeah, Oracle wouldn't grant them the trademark rights to use Java X, so they can use it as it is, but they can't evolve it.
Wow. Okay.
So like CDI and JAX-RS would be impactful.
Yeah, I'll definitely.
Maybe these other things.
Yeah, I know a lot of these are. I think it's io.microprofile. Yeah.
Yeah.
But yeah, that's a valid concern. Yeah, I don't know.
That's more just a comment. I thought the fault tolerance part was seemed pretty interesting.
Yeah, I think that's the most complicated one. The rest are pretty simple.
Yeah, it'd be interesting to maybe dive into that a little more, maybe, some other time.
Yeah, I'm not sure if
I
there's.
think looks like there's a lot of, very interesting stuff there.
I think this demo doesn't have much on it.
Like the fallback service.
Yeah, I know the at the what's the name of that? At the guides page, I was just looking at it today. If you go to this openliberty.io/guides, it has 2 different fault tolerance demos, and it goes through all of these features in detail. So yeah. All right, and the next presentation I'm going to do on a memory analyzer tool for analyzing heap dumps. So, thank you.
Great.